Today we are familiarizing microprocessor trainer kit 8085. This trainer kit manufactured by Microsystems, Chennai. Now I removed the top cover of the trainer kit. Now you can see the internal things of this trainer kit. Now you can see the power switch of the trainer kit. This trainer kit manufactured by Microsystems Private Limited, Chennai. Model number of this trainer kit is Micro 85. In our 8085 microprocessor lab, we are using this trainer kit for doing the experiments with 8085. Now you can see microprocessor 8085. This is IC, microprocessor IC 8085. This is the keyboard area of the trainer kit. We are using this keyboard for giving input and data to the microprocessor trainer kit. This is the display side of the trainer kit. This display shows our data related to input, output, etc. This is a battery, 3.3 volt battery for giving power supply to the onboard RAM. Now you can see the crystal unit for providing clock signals to the whole system. This is IC 8279 display bar keyboard interface IC. Besides this is IC 2764. This is EPROM IC. This is 8 kilobyte memory capacity. Now you can see IC 6264. This is 8 KB RAM IC. Some other supporting digital ICs are also presented here. One number of 8255, that is programmable peripheral interface IC is present here. This is IC 8255. Power supply and other components are inside this trainer kit. These are the major highlights of this trainer kit. This is the port specially made for IC 8255 programmable peripheral interface. We are connecting this port for interfacing and outside communication purpose. This is also a 26-pin connector. Now you can see another connector. This is another port for interfacing some special modules. This is 50 pins connector. For example, connecting stepper motor interface card, DAC modules, ADC modules, etc. For that purpose, we are using these 50 pin connectors or 50 pin interface port. Now we are going to discuss how to operate the 8085 trainer kit. You can see the keyboard and display of the trainer kit. When switching on the trainer kit, a cursor is displayed on the display. Now you can see the cursor that indicates our trainer kit is ready for operation. Earlier we discussed this trainer kit contains RAM and ROM ICs. 8 KB RAM and 8 KB ROM is available for this trainer kit. The user RAM area of this trainer kit is 4100 hex to 5FFF. Rest of other memory address area is reserved for system functions. So we are doing our experiments with this trainer kit with the 4100 hex starting address. You can see the reset switch. This is the reset switch just for initializing the kit. This switch is for execution purpose. This switch is for decrementing the address. This switch is for incrementing the address. That is memory address. Also numbers starting from 0 to 9 with the hexadecimal functions A, B, C, D, E, F and some other special functions switches are also placed on the keyboard. With the help of this small program, I will explain how to operate the trainer kit. From the table you can find out a address column and a hex code column, a mnemonics column with a command column. The user RAM area is reserved for 4100 hex to 5FFF hex. This is a small program that is complement of an 8-bit number. Our aim is to find the complement of an 8-bit number. You can see the algorithm of our program. First one, start. Second, load the value of accumulator from memory whose complement is to be found. Second step, take the complement of data from, that is taken the complement of data and stored in accumulator. Then store the data, that is the result. Now it is placed at accumulator to a memory location. Then we have to stop the program. So these are our algorithm for finding out the complement of an 8-bit number. Now you can see the corresponding program for the algorithm. We started our program from 4100 hex memory address location. Our first mnemonic was LDA 4200, that is load the content from memory to accumulator. That means a data stored in 4200 hex directly load to accumulator. Our trainer kit only understanding hex codes or machine codes or opcodes. So we have to feed the opcodes as per our mnemonics to corresponding memory address locations. So in 4100 hex address location we are feeding 3A, that is corresponding mnemonic of LDA instruction. LDA 4200 hex mnemonics is a 3-byte instruction, so we need 3 memory address locations to store the complete mnemonics. So 4100 contains 3A corresponding mnemonics of LDA, then 410 that is containing the lower part of the mnemonic. Here it is 00. So we are feeding 4101H to 00 hex. In 4102 we are feeding 42. Now our first mnemonics, that is LDA 4200 hex, that is successfully feeded. That means 4100 to 4102 memory address location. In 4103 here our mnemonic is complement the accumulator. That is a 1-byte instruction, so corresponding opcode is 2F feeded to 4103. As per the program, now accumulator contains the complement of the corresponding number. So we got the complement result at accumulator. Again we have to store the accumulator result to some certain location. Here we mentioned at 4201 address location. For storing accumulator, we are using store accumulator 4201 hex. You can see the comments, store the content of accumulator to memory location. Here we are going to store at 4201. So 4104 hex address location contains the first opcode, that is 32, for corresponding STA instruction. 4105 contains lower part 01 hex. 4106 contains upper part of the first mnemonic, that is 42 hex. The last part you have to stop the program. So here we are using halt instruction, that is mnemonic is HLT, corresponding opcode is 76. So we are feeding 76 to 4107 memory location or address. Now I am going to enter the above program into our trainer kit. Our kit is ready because the cursor is available at our display. Now our trainer kit is ready for program entry. In this trainer kit, now we are going to feed a complement program. So we have an 8-bit number, that is our input. So at first we are feeding the program directly to this trainer kit. First step. Second step is we have to input the data. Then third step is we have to execute the program. The last step is we have to find out the result of the program. So 4 steps are here. Now we are going to program entry. Our kit is ready. Press reset first. As per our program, our starting address of the program selected is 4100 hex. Here is a switch called sub. Press sub. Again we have to feed the address, that is 4100. Now the display shows the address field. Now it is 4100. In 4100 we have to feed the first opcode of our program, that is 3A. After entering the address, press next button for enabling data filling option. So here I am pressing next button. You can see some undefined numbers presented on data field. Here we have to fill our data, that is 3A, as per our program. So I am entering 3A with the help of keyboard. Now our first opcode is fed correctly at 4100 address location. For getting 4101, press the next button. Now you can see 4101 address field with some undefined data at data field. As per our program, at 4101 we have to fill 00. So I am entering data 00 to 4100. Now it is 00 at 4101. Again I have to go to 4102. For that purpose, press next. Now it is 4102 address. In 4102 we have to fill 42. So here I am entering 42. Now 4102 contains 42. our data. If you want to see the 4101 or 4100 content, you can press the decrement button. Now it is 4101, you can see the data content. Again I press, now it is 4100, you can see the data content of 4100 address location. So decrement button is for decrementing the address location. Now I am going to enter our last data corresponding to our mnemonics halt. Now I reached at address location 4107. Here we have to enter 76 is our opcode corresponding to the halt instruction. So I am entering 76 corresponding opcode to halt instruction, that is stop. Now 4107 address location contains 76 data. With this entry we completed our programming part. First part we completed, that is program feeding part is completed. In our program, data feeding entry is the next thing we have to do. So we are going to do the data feeding section. In our program we mentioned our data, that is the 8-bit number stored at 4200 for complement purpose. So now I am going to select 4200. For that purpose press reset, again press sub. We can select 4200. Now the address location is 4200. Here I have to enable the data field, so press next. Now we are in data field of 4200 address location. Here I am going to feed FF, that is our number for complementing purpose. So we are expecting the complement of FF. Now our data entry part is completed because we have only one data at 4200. Then we have to go to the third step, that is execution step. Now program feeding and data feeding completed, so we have to execute the program for getting the result. So after feeding data, press reset button. For execution purpose, press go. Here we have to mention our starting address of the program. Here we selected 4100. So we enter our starting address of our program, then press execute button. Now the display showing execution, that is representing E letter. A capital E is displayed now. This is showing our program is executing. Now our third step is also completed. The execution part is completed, program executed. Now we are waiting for the result. For checking the result, you have to go to 4201 location. For that purpose, press reset again, then press sub button. Here we have to enter our resultant location, that is 4201. Then press next. When I am selecting 4201 address location, that is our resultant address location. Now I am getting 00. That is our result. We inputted FF as an data at input address location. After executing the program, that is our complement program, we are getting the result at 4201, that is 00 hex. So our program worked and we got the correct result of the program. If you want to check another result, we can directly go to the input address location. For that purpose, again press reset. Our input address location is 4200. Here I am inputting 0F and I am going to execute the program. After entering the input data, press next, then press reset. Now I am going to execute the program. Go, starting address of our program, then press execute. Now program executed. Now I am going to check the result. Again press reset, press sub. Our resultant location is 4201. This is the result. Now we completed our demonstration of 8085 microprocessor trainer kit with a simple program.